Will you know in almost real time if things are going according to plan? And is there anything that we can do here on Earth if they do not go according to plan?
Yes, we get telemetry or data back from the spacecraft telling us exactly the state of deployment. So how far have things moved? And if it hasn't moved as we initially planned, there are several ways to address the electronics. You could try a different set of electronics. We have redundant electronics, or there are motors you can run forward and backward. The good thing is that once the solar array comes out and we do a small correction burn, all the activities after that can be done whenever they're ready to be done. So we don't have to rush anything, and we can take our time and get it right.
I know this is much bigger, and the mirror is obviously so crucial to it because that's where the reflected images of deep space are going to come from. But how does this differ from the results you're going to get from the Hubble? And I got to ask, am I going to get the same kind of amazing screensavers for my desktop computer that you got from the Hubble?
So we can guarantee you the same amazing shots like you got from Hubble. The mirror for Webb is bigger. Infrared light has a longer wavelength, but the mirror is big enough that the images we get from Webb will be just as sharp as Hubble images. Now, why do we look at them, or why are we doing this if we already have Hubble? Well, Webb is an infrared telescope, so it explores a different part of the spectrum, which will tell us different things about the objects. And so by having both Hubble and Webb, you can learn a lot about the physics that is driving sources in the cosmos.
And basically kind of step back in time, kind of reverse engineer how this universe began. As I understand, the device will be parked far away from the Earth. Why?
Because we're an infrared optimized telescope, that means we're measuring heat radiation. So we want to be far from sources of heat, just like if you're looking in visible light, you want to be far away from light. You observe at night. So by going far away from the Earth, we're not close to Earth, which is a big source of heat. And that's the main reason we're going to L2.
That is amazing. Dr. Eric Smith from NASA, we are going to be watching on Christmas Day, and as I know you are, hoping for the best. Thanks so much for joining us.
You're welcome. Thank you.